Alright, we're going to look at cylinder speed here. Our example is a cylinder with a bore diameter of 40 millimeters and a rod diameter of 10 millimeters is required to extend at a velocity of 0.5 meters per second. What's the flow rate required to achieve this speed? Okay, so let's take a look. One thing we always like to do first is go ahead and let's take these millimeters, convert them to meters. So 40 millimeters is 0.040 meters, and 10 millimeters is going to be 0.010 meters. Now, the rod diameter does not come into play into this problem. Why? Because we are talking about the extension velocity. What are we doing to extend? When we're extending, the rod diameter's area does not play a factor, so we're going to neglect that. We don't need that for this problem. We do need the bore diameter, though, however, to calculate the area of the piston. Okay, remember the area of the piston is going to be pi times diameter squared divided by 4. We're going to use our diameter here that we've placed into meters. So this is pi, the diameter of the bore, 0.040 meters squared divided by 4. That works out to be 0.00126 meters squared. Alright. Also, we're talking flow rate, so we know that we need to be in liters per minute. Our velocity is given to us in meters per second. So let's go ahead and correct that real quick. Just make sure we're on the right units. So our extend velocity we know is 0.5 meters per second. We're going to multiply that by 60 seconds. There is 1 minute. Okay, our seconds are going to cancel out. And half of 60 is 30, so we are at 30 meters per minute. Alright, and we're going to talk the flow rate. Flow rate for this particular problem, Q, okay, is going to be 1,000 times our extension velocity times the area of the piston. Okay, that stems from this equation that we had before. We know that the velocity, okay, is the flow over 1,000, because we're going to be doing liters, times the area of the piston. So that's an extension of this if you're used to seeing velocity is flow over area. Okay, all we did was solve this equation here to get Q. So now we can just plug in. So Q is going to be 1,000 times our VE, which is 30 meters per minute. Okay, sorry, this 1,000, that's in liters per meter cubed. Okay, and we have to multiply this by our area, which is 0.00126 meters squared. And when that's all said and done, we are at 37.7 liters per minute. Okay, so we got to check, make sure all of our units canceled out. Alright, we have this meter cancels with one of these guys and leaves it 2, but this meter squared that's left down here cancels with this meter squared, so we are just left with liters per minute. So my units worked out, and 37.7 liters per minute is our flow rate to achieve a speed of 0.5 meters per second.